Named procedures. A named procedure is a stored or database procedure. It has a name, and it is stored in the database permanently. Since it's stored in the database permanently, it can be re-executed, it can be executed again. Here is the create procedure syntax. When creating a procedure, if you simply type create procedure, etc., etc., if the procedure already exists, you will get an error. In order to recreate, alter, and recompile a procedure which already exists, you simply type create and the optional or replace procedure. Parameters in procedures require definition of parameter name plus what type of parameter they are. An in parameter is passed in by value, an out parameter is passed out by value. By value we mean that the actual value is passed in and out of the procedure. An in-out parameter is actually passed out and in by reference. In other words, you pass in a pointer to memory where the value is situated. Typically in-out parameters are used for things like arrays, by reference array variables. Every parameter must have a data type defined. Note that data types, when passing parameters into procedures in PL/SQL, are generally more general than the very strict types, such as varchar2s will be passed in simply as varchar2 rather than varchar2 with a length of the variable. Note how the procedure name and parameter definition is preceded by the keyword is or as, which is followed by a block structure. An exception trap can be included, plus at least one SQL command or PL/SQL statement. A PL/SQL procedure without any PL/SQL commands between the begin and the end block will simply fail to compile. It will give you an error. Here's the alter procedure syntax. This is very simple. Alter procedure syntax is generally used simply to compile a procedure again. The drop procedure syntax is also very simple. You simply drop the procedure. Drop procedure command will completely remove a procedure from the database. Let's go and take a look at some examples. If you can remember, in a previous course, we did a price multiplier recalculation. What this procedure will do is places that calculation into a stored procedure. The benefits are twofold. The code is in one place, it's in the database. It's not coded ad hoc or pasted ad hoc into SQL+. It's also executed on the server. In fact, there is a third benefit which is not necessarily always the case, but PL/SQL procedures generally will execute faster, mainly because they're on the server. They'll execute faster than they would on a client machine using SQL+. All this procedure does is takes in 4 parameters, namely a venue and an act name, a show date, and a price multiplier. Note that each show is listed on the table called show and is referenced through the venue and act tables by a show ID. Since the show ID is an internal unique identifier, we don't actually know what it is, but we do know what the venue and act names are. What we do then is we update the show table and we set the price multiplier equal to the price multiplier update, the change in the price multiplier column, and we restrict the record we're updating to a unique show by specifying the show venue ID as being a subquery based on the name of the venue. The act is linked to a subquery based on the name of the act, and we specify an exact show date equal to an exact show date value, which is passed in as a parameter. All we're doing at that point is simply outputting the values that we've changed with DBMS output. Let's copy and paste this procedure into SQL+ and run it. So we've created the procedure. The / command has actually created and compiled the procedure. Now what we'll do, in order to make absolutely sure that our procedure is correct, is I'll show you the alter procedure command, which will compile the procedure. If there are errors in the procedure, you would simply type the command show errors, and it would show you any errors that the compiler had detected. And then you could take action to correct your code and sort the problem out. Now what I'm going to do is I'm going to try to find some rows to change. First of all, I'm going to set columns so I can see the details coming out. I'm going to set the pages to 80 lines so that I don't get headings all over the place. And then I'm going to run a join between the act, show, and venue that validates against the ticket table. So I'm trying to find act, venue, show combinations that actually have tickets. There's no point changing a price multiplier for shows that don't have tickets, not at this stage anyway. So let's run this code. The result of that query gives me 42 shows which have tickets in the ticket table. So now what I'll do is I'll go back to my script, and I already set up some shows that I wanted to change. I just wanted to show you where that information came from. So I'm going to change price multipliers for this particular venue and for these particular acts with shows on these particular dates, and we'll see the result that comes out. Once again, I'm setting server output on, I'm executing the commands, and I'm setting server output off because I'm using dbms output. Let's run that. As you can see, we have price multiplier changed to 1.25 for sticks at Compaq Center on 14 December 02. If any errors were detected, it would have given me an exception for one or more procedures and continued executing the next procedure. Here I've got the description for each change. So that's fairly simple. Since I don't want to keep that procedure in the database, I'm simply going to drop it again.